closely with the White Birch Lake Association, and they have done previous management before reaching out to us for help in creating a management plan for their lake. Um, Currently, I'm developing a state of a lake report and a management plan for their lake. Previous management they did do for the lake was they had a horrible sediment problem over the last 15 years where they were losing depth from their lake, which originally was built, it was about 18 feet deep and currently sits at 14 feet deep. So they created sediment catch ponds on the north end to try to minimize the amount of sediment that's getting washed into the lake. This is a very small watershed that the lake sits in. It's about 77 acres. And they also stocked grass carp due to fears that they were having too much plant growth in their lake. Currently, they are not continuing stocking of grass carp, and they haven't done it for many years. They also participated in the Citizen Science Lake Assessment Program for 7 years, with first starting around the late 1990s and taking a break until about 2013, where they did it for about 3 years then. So their biggest concerns when coming to SUNY Oneonta and asking for a lake management plan was they want to know the current state of their lake. They're very conscious on being able to preserve the resource they have, and they're worried about preserving it for the next generation. They are also very nervous that this lake is going to fill in and they're not going to have a lake soon. They also want to know what management they can take. They have done previous management with grass carp, sediment catch ponds. They've also, some stakeholders have said that they've done some chemical treatments, but there is not a clear census on what information about that has come out yet. So they want to know what the most sustainable practices for their lake are. My current methods for creating the state of the lake report and then eventually the management plan is we took data from the internet and government resources and analyzed the watershed for septic suitability soils, land uses, and also location to areas of major concerns. So it'd be like farms and other like wetlands and stuff. I am also conducting uh, bi-weekly sampling, vertical sampling at the deepest point in the lake, which is about 14 and a half feet on the south end, right near the dam. In this sampling, we are taking zooplankton surveys where we do tows from the bottom all the way to the top. We also take water samples so we can run a variety of tests back in our field station, which some include alkalinity, chloride, total phosphorus. We are also doing uh, taking water samples and bringing them back to analyze chlorophyll within the water. And we are conducting temperature and oxygen surveys throughout the year. Our whole goal with these biweekly surveys is to be able to make a full uh, timeline of the whole year and see how the lake changes as we go through months. We're also part of my project is each student is allowed to kind of after limnology stuff is allowed to kind of work with their stakeholders and what is feasible and be able to kind of tailor their masters to what they want to do. So I am doing I'm also testing for aquatic plants. They really are curious what's in the lake. They never had a formal plant survey done. So it'd be really interesting to see if it's a lot of natives or invasives. They are also very curious about septic systems leaking into their lake and ruining the water quality. So we're going to conduct a fecal coliform survey to see if septic systems are leaking. The map on the left is kind of just a location map of where White Birch Lake is in New York. The top part, figure two, is me out there sampling. This was roughly in about January, February, where the ice was thin enough that I was able to take a john boat and break my way out. And I was also able to collect my temperature and oxygen samples with a YSI. Um, Currently, I'm in my first year, like I said, so I don't have too many results yet. But for our winter sampling, our biggest concern was rapid temperature changes throughout the months, and of lack of oxygen at the bottom, which could turn the water anoxic and kill the fish. Luckily, through our sampling, we found that the temperature kind of stays consistent and stratifies, not strongly, but enough. Oxygen was super high, which supports a lot of life. And we also kind of went and analyzed the land cover. Uh, One of the best parts about the land cover, it's about 60% forested, and the areas that are developed are just open areas. Most of the development around the lake is on the edge, and it is actually very forested and hilly around that area. Um, my next steps for my project is this spring I just finished taking bathymetric mapping samples, which I'll be able to create a depth map for the lake. I'm also going to be analyzing the 7 years of data collected in the Citizen Science Lake Assessment Program and working with my stakeholders to gather historical information that they want to provide about previous management. And then I'm going to be also conducting present absent plant surveys and sediment input. I'd like to thank and acknowledge the White Birch Lake Association for allowing me to come out and work on their lake, the SUNY Oneonta Biological Field Station for helping me run my samples and provide me the equipment, and the volunteers from the Citizen Science Lake Assessment Program that took the samples at the lake, and also the volunteers that trained the volunteers on how to collect these samples. At this time, if you have any questions.
So a quick question about the grass carp, which predates your involvement. I was They just did that in terms of vegetation in general. They weren't after a specific invasive like Eurasian milfoil or anything like that.
One of the previous concerns for the lake was they wanted less plants so they could use it. It's very recreational. So a
Yeah,
lot of people boat, swim, and their whole idea before they kind of understood the scope of grass carp was they wanted less plants.
yeah,
So they dumped it in there and now they're just done doing that because it has kind of wrecked their ecosystem.
yeah. Cool.
Thank you, Alex. Sorry again, everyone. I was a little late. I was having some technical issues getting in here, but we are going to move to the next person. I have Nicholas up. So Nick, if you want to share your screen, I'm going to go ahead and start the timer as soon as you're set up.
I'm all ready.
All right. 8 minutes starting now.
All right, gotcha. So I'm Nick Freese. I'm a graduate student from SUNY Brockport. I'm finishing up my master's in environmental science with a focus in fisheries. My project focuses on determining what the diet of lake trout from Otsego Lake is. Otsego Lake is located about an hour west of Albany. For those that are Finger Lakes oriented, it's about the same size as Canisius. It's just much deeper. It's about 162 feet deep. So as with much of New York's waters, Lake Ontario has had a history of introduced and invasive species with records dating back all the way to 1935. The main invasive that is a focus of my project is alewife, which is an invasive herring present throughout the Great Lakes, most of the Great Lakes, and some of the Finger Lakes. As well as previously Otsego Lake. It was introduced in the mid 80s, and then through various management practices, it was extirpated by 2012. And they really had an understanding of what lake trout were eating previous to alewife's introduction, during alewife's introduction, but they haven't done a significant analysis of what they're eating currently. Before alewife were introduced, they were eating mainly slimy sculpins and chironomids. During alewife's presence, they skyrocketed into eating almost 80% of their diet being alewife. And then since alewife are no longer an option, it's a big question about what they're eating now. So I'm not going to get into my methods too much based on time limits, but my samples were collected collected seasonally from the fall of 2021 through the spring of 2023, with lake trout only being collected in the fall. And we used liquid chromatography gas chromatography to determine the fatty acids that contributed to the lake trout and prey fish's diet, as well as sending carbon and nitrogen samples to University of California, Davis for carbon-13 and nitrogen-15 analyses. So moving into my first analysis, we looked at the stomach contents of lake trout. And if you look at this graph I kind of zoomed in on, you can kind of see that we had a pretty good variety of macroinvertebrates and fishes, as well as some lake trout eggs stuck in there. Obviously, lake trout eggs are a seasonal option for lake trout to consume. So if we look at the two different metrics we have here, we have wet weight, so purely the weight of each individual species within the stomach of a lake trout. We can see that rock bass, yellow perch, and cisco are overwhelmingly dominant, with rock bass being prominent. However, unfortunately, that one bar represents one fish in one fish's stomach. So it's by no means representative of lake trout diet. It just happened to be a relatively large lake trout eating a relatively large rock bass. So we more looked at our frequency of occurrences, which is just how many stomachs had each prey type within them. And we can see that chironomids and dracinid mussels are dominant, as well as slimy sculpin for the fishes. And we kind of ranked those three as the higher priority. And since slimy sculpin are also ranked relatively high for the wet weight, we kind of ranked it as slimy sculpin, chironomids, and dracinids being the dominant prey reflective of this analysis. Moving into a fatty acid analysis, fatty acid analysis operates under the assumption that you are what you eat, plus or minus a little bit, so that we can look at the fatty acid signature of the prey and find it relative to the predator. So this graph pretty much just shows the fatty acid signature of each individual prey that we use for an analysis, with each point representing 25 different the concentrations of 25 different fatty acids within each prey. And we can see that the different prey plot together by species, more or less. So we have our sunfishes over here, our slimy sculpin down at the bottom, our rainbow smelt over here, and then a yellow perch made up in the center. And the important thing to take away from this is that an assumption of this analysis is that the prey's fatty acid signatures are significantly different from each other. And both statistically and by seeing these groupings, we can say that they are significantly different enough so that we could run some more quantitative analyses. And using some R modeling, we saw that the diet of slimy sculpin, or the diet of lake trout, was mainly slimy sculpin, bluegill, dracinids, and rainbow smelt, with slimy sculpin having 45.8% of the diet, and then all the other fish falling around 20% of the diet, respectively. And then we saw similar results when we looked at our stable isotope results. We ran some R modeling for the stable isotope using the Mixar package. And we found that after 3 million permutations with all Gell-Mann statistics falling below 1.05, which just means that the prey are well represented within the diet, that rainbow smelt, slimy sculpin, and dracinids were dominant prey. So very similar to the other two analyses. So given that if we take all three different analyses into account, what we're found is that the main diet of lake trout in Otsego Lake, at least in the fall, consists of slimy sculpin, rainbow smelt, dracinids, and to a lesser extent, chironomids. I would like to thank Brockport students for their help during collections and analyses, as well as students, staff, and faculty from SUNY's Oneontas, Cobleskill, and New York State DEC's Region 4 Fisheries Station, as well as the Great Lakes Research Consortium, just the Brockport Distinguished Professors Award, and the Department of Environmental Science and Ecology for funding. And I think I have about a minute and a half for questions. I know that was a lot very fast, but I have a lot of analyses.
Thank you, Nicholas. Megan, I know you're here, so we can go ahead and get you started. And I will flip this around.
Okay. And for the moderators, just so you know, Jared Ludwig had last second, something came up last second, so I will also be doing his poster.
Okay, sounds great. Thanks for letting me know that, Nick.
Yeah, of course.
All right, this looks good, Megan. I'm going to go ahead and start your 8 minutes.
Can you hear me okay?
Yep.
Great. Well, hi, everyone. Thank you so much for being here. My name is Megan Holton, and I'm a second-year PhD student in urban and regional planning at the University of Buffalo and a graduate research assistant in Nicholas Rakovich's Resilient Buildings Lab. So residential energy efficiency upgrades, such as insulation, sealing, heat pumps, vapor barriers, smart thermostats, offer the promise of cost savings, reduced emissions, and improved individual and community health and well-being. But is energy efficiency always good? Today, I'm going to walk you through what has been a very iterative process of understanding this question and its policy implications. Some context on my position to the research. Before I started this PhD, I was a practicing planner for 10 years, and before that, I worked as a circus artist and an instructor. In between my classes, my research assistantship, work, and being a mother, this question has been at the back of my mind. Was it possible to integrate my previous work in doctoral, in the circus arts and public space with my doctoral research? Enter Rosie Simas, a dancer and distinguished visiting scholar through the UB Visiting Scholars Program. She asked me, what would it mean to embody my research question? Ever since I transitioned from circus artist to the profession of planning, I recognized the connection between the engagement of the audience in physical theater and the engagement in the public in the processes that are core to community planning traditions. This also extends to research spaces. The people I am learning with and from and the tools that are available coalesce around the research questions that are in conversation with context. Just like in a circus where the venue of a street show or black box theater will affect how long the show is, whether there's a story, and whether you can use fire or mime to tell your tale. This conceptual diagram on the lower left makes explicit what likely happens for many of you in your scientific inquiry, talking with others, thinking of the broader impact and audience, sharing and refining the question, all happens in science regardless of how linear it gets laid out on the page. Method. To better integrate my processes and question, I did a circus arts mini residency in the Grow Home, which is a net zero energy house on UB's North Campus in the second half of the semester, where I spent 2 hours once a week, every Wednesday after a class I had on that campus. And here I'm going to share with you 3 vignettes of what I would round up to data analysis. Despite my initial, so we're looking at A now. Despite my initial intention, it became apparent that it would be impossible, along with all my other commitments, to actually put on a circus show. So I settled on a graphic novel about putting on the show and these ideas. You'll see these draft sketches on the poster. Let's start with figure A. The first was a question of audience. The Grow Home is about 600 square feet with a capacity of 50 people and is a good 10-minute walk from any density of activity on North Campus. It's positioned adjacent to UB Solar Field as a symbolic and material entrance to the campus. Rosie asked me, what does it mean for your research question that the audience is far away? This turned me to the concept of use and access to residential weatherization assistance programs. How do we come to value the energy efficiency of a building like the Grow Home, but something like a theater with its bright lights and voluminous spaces and joy making that is periodically home to hundreds of people doesn't get labeled as energy efficient? Now you can turn your focus on figure B. What if we were to abstract these themes to the idea of energy efficiency and the math that goes into making these calculations? Energy efficiency is often measured in what's called energy use intensity, or EUI. It's like the miles per gallon of the building world. My 1920s rental in Buffalo, New York has an EUI of 84. So that's the energy used annually divided by the floor area. A lower EUI is better. But there are 2 ways you can get there. One of the ways you get there is by insulating your home, replacing your water heater, sealing all the leaks up. And the other way you can get there is by reducing your energy use, which is something that happens all of the time. Low-income households are paying around 13% of their household income on energy, whereas the general population is paying just 3%. Yet energy efficiency policies incentivize the former approach. In the current rate structure for natural gas, the unit cost of gas goes down the more you use. EUI is calculated as energy per square foot, but you get a very different type of number when you divide by square feet versus divide by household versus divide by household occupants. Again, the current policy landscape seems to incentivize or at least reward buildings, material things, and consumption rather than the occupants of those homes, which is not that surprising. US housing policy is full of examples that privilege the nuclear family and single-family homes. Section 3, down at the bottom. Donna Haraway offers an analytical approach called Writing the Implosion to understand the history of everyday technology and objects. Many of these tools used to document buildings' energy efficiency, such as thermal imaging, shown up in the right, began with military surveillance and control. Infrared sensors now used to gauge thermal heat loss of buildings, see the upper right kind of, were first developed as part of anti-aircraft campaigns, are now used at the Mexico-US border to abstract the humans who are crossing into numbers to be counted, controlled, and excluded. There's a deep entanglement between the US military and corporations like Honeywell and Texas Instruments to produce this technology. Who does it benefit? Producers and consumers of new things. Results. As my one-woman circus show turned graphic novel residency evolved over the past semester, it was becoming clear that this little home was actually a terrible place for a circus show. The audience is too small. It was hard to control the sound and lights to tell a story other than one about thermal dynamics, or at least the type of show that I was used to. There were certainly plenty of audience that was moving through. They were just moving through very fast, every 5 minutes, in fact. The UB Stampede, which is the bus that shuttles students between 3 campuses spread across the city of Buffalo, would pick up students who were huddling chillily in the unheated bus stop as I spun my plates in the relative warmth of a net zero energy house. My audience. From there, the 3 aspects of this investigation really came together into the video that you see on the upper right. And while this isn't on the poster yet, as I'm still finishing up this project, this semester, this micro residency, the idea here is that we're going to take this image, which is an overlay of the thermal efficiency and thermal performance of the grow home, and then project, and with me juggling on it there, and project this image onto the grow home itself, onto the side of the wall that faces the people who are sitting there, standing there, waiting for the bus. So what does it mean to embody my research question in this method? Playful routine movement is always going to be part of my process. The limitation of this approach is that this art is both a joy and a mirage that puts some space between me and the critical inquiry that I engage with. I can sort of bypass my own positionality as a settler who is perpetuating and still using these technologies. However, this art space also acts as a binding or a bridge that connects me with an audience that is more distance from either the technology, the skills, and the policy that implies, or the research that is needed to do this work. And I think that's okay. Pushing back on the essentialism of good versus bad is how my art can be both a refusal and reformist to the current system. And as nudged by Meredith Palmer, a better question might be, is what good does energy efficiency actually produce? For whom, how, and where? Thanks so much.
Great, thanks, Megan. Right on time. You're 5 seconds away. That was perfect. All right, I know next up we have, is it MD Sahadat? I have you next.
Yep.
Perfect. All right, so we can get your screen shared and then I will start the timer as soon as we're set up.
Can you hear me?
Yep, we can hear you and we can see your poster. So I'm going to go ahead and start your 8 minutes. You're good to go.
Great. Thank you, Megan. Welcome, everyone. I am Sahadat Hussain from SUNY ESF in Syracuse. And this is one of the part of my PhD research, where we have been working under the direction of Dr. Timothy Bock here. So my research is mainly focusing on to see the sustainable bioenergy production and supply to address the net zero emissions for the state. And for that, answering this question, so we have like a couple of steps to see where the sustainable biomass feedstock can be grown, and then what could be the potential production, and then finally what will be the net carbon emission reduction potential from that areas. So very beginning, just I wanna just mention a couple of issues here in my introduction. New York State has has adopted one of the Climate Act in 2019 that is has a target to reduce 40% of its GHG emission by 2030 and 85% reduction of GHG emission by 2050, and eventually New York State will achieve a net zero emission or net zero economy throughout the state. So based on that, New York State, for addressing that one, New York State has prioritized on the biofuel production in addition to other renewable energy, for example, solar and wind, hydro, these kinds of, but still biofuel production has a great emphasis in the goal and different strategies. So in align with the act, there was a scoping plan has been developed by the state government that is that has shown different potential targets and also like the potential demand of the feedstocks that could be needed to address the climate act by using the biofuels. And we have analyzed that one of the scenario out of 5 that is saying like there will be like 315 to 345 TBTU energy bioenergy will be produced from the biomass feedstocks by 2030 and 2050, and that actually needs around like 30 million megagram of biomass and by 2030 and 40 million megagram by 2050. So this huge amount of the biomass actually currently New York State has a biomass potential only 14 million megagram, and in which 62% is from waste production. So it says, and currently there is no energy crops or the biomass production, which is especially special crops or energy crops could be used for the biomass production. So there is a huge potential or activity New York State needs to take in account to address these biofuel production issues. So in our objective, that's why we have analyzed the potential lands that can address here. You see in my objectives, like to quantify the total lands, New York has 12.7 million hectare lands, and we have developed 3 kinds of scenarios, including agri-land, excluding conventional crops from the agri-land, and excluding all kinds of food production crops in along with the developed area, forest area, water area. And we here actually in the poster we are just showing our no crop scenario. That is the scenario didn't include any kinds of forest land, any kinds of water developed, and also the cropland, so that we can avoid some of the kind of the conflict or concern about food versus energy and other biodiversity issues. And we found like 1.98 million hectares land, potentially the idle lands in the New York State, which are mostly comprising the shrubland, herbaceous land, and also barren land. And we use different kinds of variables that can work as a growth restraining factors for the willow, especially the energy crops of willow. And then we found like, for example, the erodibility, distance to the water bodies. So different kinds of factors that can restrain the growth of the willow. And for the suitability analysis, we found like around like 1 million hectares are potentially suitable land in the New York State. You see in the graph in the middle of the bottom, you see like the distribution of these lands. They can actually give you around 14 million megagram of biomass production only from the energy crops, that is willow, and that's 98.8% will come from the shrubland. So you are not intervening with the forest and crop and other kinds of special areas that can be a concern for the scientific or the political community. So that means the New York State has a ample potential for producing energy crops, especially the willow, and that can address around like 50% to 50% biomass by 2030 and 33% of the total biomass demand by 2050. So this is actually very huge potential for the state that New York State can address its net zero emission goal, and maybe New York State can utilize the potential lands that can be utilized for producing the biomass, and that can be utilized for the potential replacement of the fossil fuels, which has a very big impact on the GHG emission, also economic on the from the economic emissions, and that can be helpful to achieve the zero emission goal by 2050. I mean, the target can be fulfilled by the state from the biomass production, especially from the energy crops, without intervening any concerning issues. Our next step is to utilize these lands to see what are the geospatial potential for the net carbon sequestration in this land, so that we can identify the most hotspot land. And also we are using a couple of variables in that case, for example, like the transportation potential site for establishing biorefinery, so that the net emission and also the per unit cost and per unit CO2 or GHG emission can be estimated, so that it can be communicated to the policymakers actually for the betterment of the state and achieving the net zero emission goal by 2050. That's it. Thank you. If you have any questions, I can try my best.
I've got just a quick question. You've identified a lot of potential here for biomass production and carbon sequestration. What will be needed for that potential to be turned into, actual use?
So currently, we have like 64 plots in the under the ESF is also in collaboration with the Cornell University and Pennsylvania State University. These are mostly the research plots working on the different types of willow variety. And the most essential needs is the investment cost of what we are currently presuming that might be the commercialization needs lots of capex. And also there is a concern of the zero combustion or combustion away for the state that might be an issue, but I would prioritize the capex would be the biggest challenge for implementing the bioenergy in the state.
Thanks.
Thank you.
Thank you, Sadat. We've got next up we've got Aisha. I saw you in the room. Perfect. So if you want to go ahead and get set up, I'll start your 8-minute timer and we can get started. Oh, you are muted, Aisha. I can't hear you.
I'm finding it difficult to share my screen. Just give me a minute. I think this should be it. Yeah, so you guys are on my screen now?
Yep, we can see it. Looks good.
Okay, great. So this is Aisha Iftikhar, and I'm a Fulbright PhD candidate at SUNY ESF, and my major is environmental science, and I'm working in wastewater treatment and resource recovery. So this today I'll be talking about screw-white recovery for organic production, mineral-based magnesium supplementation, and pH elevation. So first we'll talk about the introduction. Organic farming systems rely on fertilizers that are solely obtained from organic sources. They are typically low in nutrients and they depend on soil microbes, so their yield is usually lower than the conventional fertilizers. To mitigate the complications of phosphorus pollution and its limited availability, its recovery from wastewater in the form of screw-white aligns well with sustainable wastewater treatment and circular economy principles. Concentrated mineral fertilizers, if recovered from wastewater without chemicals according to the organic farming standards, may supply nutrients to increase the productivity of organic production systems. In this study, we introduced a novel approach to utilize two mineral-based products for magnesium supplementation and pH elevation to recover screw-white from sewage sludge anaerobic digestate filtrate. Screw-white is a mineral containing phosphorus, magnesium, and nitrogen, that can be used as a slow release fertilizer. There are two major objectives of this study. First is to investigate the combined application of calcined magnesite to elevate the pH without using alkalis, and Epsom salt to supplement magnesium for chemical-free screw-white recovery from filtrate of sewage sludge anaerobic digestate for subsequent use in organic farming. The second one is to determine the phosphorus recovery efficiency by the combined use of these two minerals and screw-white purity from the recovered precipitates. So as far as the materials and methods are concerned, the first step was to calcine magnesite, which is MgCO3. It was calcined in a furnace for 30 minutes at 800 degrees Celsius. And as a result, we got calcined magnesite, which is magnesium oxide, as most of the carbon dioxide has been released during calcination. Then we tested pH elevation with calcined magnesite, and we used three kinds of wastewaters: supernatant of anaerobic digestate from a thickener, filtrate of anaerobic digestate from a filter press, and filtrate separated from anaerobic co-digestion influent from sewage sludge and chicken manure. First, we stirred these water in 250 ml beakers, and they were stirred for 30 minutes at 130 RPM to purge carbon dioxide. Calcined magnesite was then added gradually to develop dosing curves for pH increase. Next up, the next part was screw-white recovery for dosing two mineral products. So we used this crystallizer that you can see on this slide here. So we used filtrate of anaerobic digestate. Phosphate concentration was 5.70 millimolar in the filtrate, and crystallizer were run for 30 minutes to purge carbon dioxide, just as we did this step with the beakers. Then we added 374 milligram calcined magnesite to supplement magnesium, and at the same time increase pH to 8.5. 8.5 is necessary to precipitate out screw-white from wastewater. Next up, we added 2.389 gram Epsom salt, which was added at a magnesium to phosphate molar ratio of 1.2. pH and conductivity was throughout monitored. During these experiments, phosphate, magnesium, and calcium were monitored based on hourly basis. After 3 hours of crystallizer run, sieved filtrate was analyzed for phosphate, magnesium, total ammoniacal nitrogen, and calcium. Air-dried crystals were characterized by SCM, EDS, FTIR, and XRD. Crystals were further acid digested for analyzing phosphate, magnesium, and TAN concentrations to determine the screw-white purity. Well, for results here, so as shown in this figure 1, purging carbon dioxide did increase the pH in shallow beakers, which increased by 0.1 to 0.17 to 0.31 in sludge digestate in half an hour, and it increased 0.51 in co-digested influent in 1 hour. These dosages of calcined magnesite to reach pH 8.5 was 213 to 230 milligrams per liter for sludge digestate, corresponding up to 5.29 to 5.71 millimolars of magnesium increase. Therefore, further magnesium supplementation is still required for effective screw-white recovery at magnesium to phosphate molar ratio of 1.2. In the second image, filtrate pH increased by 0.60 upon 0.5 hours of air sparging. This is from inside the crystallizer. So air sparging played a major role in increasing the pH to by 0.6 upon half an hour of mixing. Next up, our addition of calcined magnesite increased the pH to 8.5 within 1 hour of addition. And then we added the rest of our magnesium in the form of Epsom salt to recover maximum possible phosphate from this wastewater. As pH was increased by air sparging, phosphate concentration spontaneously decreased by 47.5%, likely due to the precipitation of screw-white and blueshite. Based on the relative decreases that we can see in this table in magnesium, phosphate, and calcium, molar concentrations, when pH was higher after adding calcined magnesite, phosphate concentration continued to decrease quickly due to the precipitation of screw-white plus hydroxyapatite. The lower decrease of magnesium and total ammoniacal nitrogen than phosphate also indicates that some of the phosphate has precipitated as crystals other than screw-white. The average phosphate removal efficiency was 98.5%, which is pretty high than the other past studies. Here we have the SEM image of the screw-white crystals, and then this one is the SEM EDS mapping, which shows oxygen, nitrogen, magnesium, phosphorus, as well as some calcium in there, which our other results are also indicating that some calcium also precipitated along with the screw-white here. So next up in this table, the percentages of constituent ions in the recovered powder where phosphorus is greater than both magnesium and tan. It is also indicated that additional phosphorus precipitated as calcium phosphate or hydroxyapatite. The harvested crystals were said to be 81.5% struvite. And then next up, we have the FTIR results for our recovered struvite crystals. So down there, we have the reference struvite, and up there, we have the crystals obtained in our study. And next up, we have the XRD analysis. So reference struvite is the blue down there, and the red one is our crystals obtained in this study. Next, we did the cost analysis. I would not go into the details, but I would tell you the cost that we obtained for the material and energy cost, and it was $0.94 per kilogram of struvite produced. As a conclusion, chemical-free struvite recovery from wastewater produces natural fertilizer suitable for organic farming. Two mineral products, calcine magnesite and OMRI listed Epsom salt, can be combined at different ratios to simultaneously supplement magnesium and raise pH for a variety of wastewater streams without compromising struvite recovery efficiency and its purity. Calcine magnesite could be quickly dissolved in wastewater to raise pH to above 8.5 and supplement magnesium for struvite precipitation. More than 98% of phosphate was removed from the filtrate of sludge digestate in 3-hour batch operation, producing crystals having a high fertilizer and pK rating of 5, 29, and 0. Next up, I have my references here and my acknowledgements. Thank you so much.
Great. That was perfect timing. I think you folks can hear the timer. It's like a fun little jingle. But thank you very much for sharing. It was great. I know next up I have Alexander Yavitz. I thought I saw him in here earlier, but I'm not seeing him on my list. Alex, are you here?
So Alex's session crashed, so he's trying to get back on right now, but currently he's not here, so he's having a few technical difficulties.
Okay, no worries. We can always so I'll probably go on. Jing'an, are you ready? I know that you were listed up after Alex.
Yes,
Perfect.
yeah, I'm ready. Okay.
Okay, that sounds good. So if Alex comes, we'll just have him go right after you, but we'll have you go for right now just so we can keep things moving. All right, I can see your screen. I'm going to go ahead and start your 8 minutes. You're good to go.
Okay. Hi everyone. I'm Jing'an Lin, and I'm from Stony Brook University in School of Marine and Atmospheric Science program, and I'm working in New York State Center for Clean Water Technology. So today my topic is about temperature-dependent nitrate removal in water media. So we all know that in Long Island, there's a problem of coastal eutrophication, and part of the reason is due to the excessive nitrogen input through submarine groundwater discharge. And so one of the solutions to this problem is permeable reactive barrier, PRB, as you can see in the figure 1 here. As you can see a figure here, it's basically a trench system filled with wood chips, and this wood chip can serve as a carbon source for microbially mediated denitrification and can remove nitrate before it enters coastal oceans. It's promising because it's cost effective, and also it doesn't require any energy. However, it can be constrained by oxygen penetration into wood media because oxygen can inhibit denitrification. So in our study, I want to assess oxygen penetration into wood media for different hydraulic residence time and at different temperatures and impacts on nitrate removal performance. So now look at our materials and method. So as you can see here, the figure at the left, basically we conducted 1-year-long bottom-up flow-through column experiment with 4 different types of water media to assess nitrate removal rate and also oxygen penetration for different residence time and groundwater temperature 7 and 14 Celsius degree. And so basically oxygen penetration was assessed by planar optoimaging, as you can see this figure at the right. So oxygen penetration, as you can see here, there's a down gradient of oxygen concentration from bottom to top. This color bar represents the percentage of air saturation. So because oxygen is supplied from the bottom, and when it goes through the columns, the Wuchip media will consume oxygen. So as a result, oxygen will become lower when it goes through the top of the columns. So through this, we can understand the oxygen distribution and how much oxygen is consumed in the columns and how far it can penetrate into the columns. Okay, so now let's look at the result of oxygen penetration. As you can see, figure 3 here, I show the steady state oxygen distribution in different wood chip types. The wood chip types include oak, pine, a mixture of oak and pine, and also mixture of maple and cherry columns. So as you can see here, the different type of the wood chip, they have different performance. So clearly you can see pine softwood have a higher OPT oxygen penetration than other type of the wood chip columns. And okay, we can see OPT increase with decreased HRT for each column, and also it increase with decreased temperature. So we can see here at 14 degrees, the saturated O2 concentration is 10 milligrams per liter, and at 7 degrees, the O2 concentration becomes 12.1 milligrams per liter. So the temperature can impact in oxygen penetration in that first, at lower temperature, oxygen has higher solubility. Also, when temperature gets lower, microbial activity also becomes lower. So there will be lower oxygen consumption. So at temperature, we see a higher oxygen penetration. Now you can look at figure 4. Figure 4 represent the mean OPT of different type of wood chip media at different residence times and temperatures. So you can see that OPT initially it drops significantly from 0.5 HRT to 1 day HRT. Then the variation becomes smoother from 1 day HRT to 2 day HRT. So it shows a exponential performance. And we can see at 1 day HRT, OPT of the pine is around 61 centimeters, but the OPT of other type of wood chip media is range between 23 to 29. So they are around 35 cm difference. And let's look at 7 Celsius degree. At 1 day HRT, again, you can see a pine have a 98 centimeters of the OPT, and the other type of wood chip have around 40 to 48 centimeters. And the difference range are between around 50 centimeters. So we can see how many different between the performance of pine from other types of the wood chip columns. Now let's look at the nitrate removal performance of the wood chip bioreactors. So basically, we can see that nitrate removal rates decrease with the increasing HRTs. We can see it from these figures. Let's look at the upper part of the figure. This represents the nitrate removal rate at different residence time and temperature. So we can see at 2 day HRT, nitrate removal rate is a little bit higher than nitrate removal rate at 1 day HRT. And at 14 Celsius degree, the ratio between 2 day to 1 day is around 1.2. And at 7 Celsius degree, the ratio of the 2 day, the ratio of nitrate removal rate of 2 day residence time to 1 day residence time is around 1.3. So slightly higher at 2 day. This might be due to, this might be caused by the oxygen penetration at different residence time. As you can see, at lower residence time, there's a higher oxygen penetration, so it will inhibit nitrate removal rate, and so we can see a little bit lower removal rate at 1 day residence time. To eliminate the effects of the oxygen penetration, so I did this calculate. Basically, I use nitrate removal rate here at upper part of the figure, divided by the percentage of the anoxic volume, which is defined by the percentage of the area smaller than 5% of air saturation in the columns. So now I got the results at the lower part of the figure. I call it nitrate removal rate by anoxic zone. So I can see that the difference between 1 day and 2 day residence time became closer to each other. So we can see at 14 degree, the ratio is 0.96, and at 7 degree, the ratio is about 1, so pretty close to each other. So from here we can see how oxygen through divided by an oxygen volume, how we can eliminate the effect of oxygen penetrations. So here is our major conclusion. We know oxygen penetration distance decrease with HRTs and temperature. Also from the result of nitrate removal rate and adjusted by an oxygen volume, we can see the nitrate removal rate of PRB is constrained by oxygen penetration. Also the loss of an anaerobic PRB media under high flow and low temperature conditions should be accounted for when choosing the thickness of a PRB to warrant a complete removal. And here's my reference, and thank you for the NYSDEC for funding. Okay, thank you.
Great, thank you, Jing'an, right on time. All right. I know we just skipped over Alex. I don't see Alex back yet, Alex Yavitz. So next I had Jared, which I know, Nick, you said you were going to be presenting on behalf of Jared today.
That's correct.
Okay. So why don't we go ahead and get you set up for that, and we'll see if Alex joins us later on, and he can always go if he gets here at a later time.
Sounds good. There we go.
Perfect. I'm going to go ahead and start your 8 minutes. You're good to go.
All right, thank you very much. So I'm Nick Freese again. I'm filling in for Jared Ludwig, who's finishing up his master's at SUNY Brockport, also in fisheries. His project focuses on determining the thymine concentration of lake whitefish throughout the Great Lakes system. So salmonids throughout the system, so your salmon and your trout, have had a history of having thymine level issues in the past. And thymine deficiency can limit your ability to produce offspring that have proper neurological development and can lead to both primary and secondary mortality. So they can either just die outright if their vitamin levels are too low, or they can just be easier to consume because they have improper swimming technique and other secondary effects. So it's really been a question on whether this has been an issue for lake whitefish, because their populations have been low since the mid-1900s, but have significantly dropped in recent years. So the thought is that with the spread of the dracaenid mussels throughout the Great Lakes system, that the consumption of these mussels by lake whitefish may limit their thymine storage. Because dracaenid mussels have high levels of thyminase, which is an enzyme that can break down thymine within the body, it has been a point of concern. So this is a pilot study to determine whether lake whitefish have any thymine deficiency and kind of put a baseline at what their levels are currently in the lake. So an interesting point is that going into this study, it had been expected that Lake Superior was going to have the highest concentration of thymine within their eggs, because Lake Superior does not have a significant level of dracaenid mussels because it is too deep and it is too cold. And so it had been thought that their diet would be diverse enough to produce eggs that had higher levels of thymine. However, when we look at our graph down here, we can see that the exact opposite was true, in that Lake Superior had the lowest levels of thymine within the eggs, whereas Lake Erie was shown to be the highest, with differences between the eastern and west basin, with the eastern basin of Lake Erie being higher, but the western being more diverse. So there's a chance that the diet within the western basin might be a little bit more diverse than it is on the east. But we can see that with our different levels here, that there is not a significant difference between much of the lower Great Lakes versus the higher Great Lakes, and the higher Great Lakes, Lake Superior and Lake Huron, are lower, with also one section of Lake Michigan. And also an unexpected result of this project was that the vitamers, so the different forms that thymine takes within the eggs were against expectations relative to previous studies done on salmon and trout. In salmon and trout, TH is generally the overwhelmingly dominant vitamer within the eggs. TH or free thymine is the storage component of thymine, whereas thymine pyrophosphate is the active form, so it's the form that can be more used within the body. So in salmon and trout studies, TH is overwhelmingly dominant, and while it is in relatively higher concentrations for some of these different areas, the active form of thymine is in much higher levels than it has been seen in previous salmon and trout studies. So basically, the results of this study have been kind of indicating that we need to do more research on what is going on for lake whitefish. They're not following similar trends that we were seeing in salmon and trout studies. And we can't really say whether they are thymine deficiency or not, because there has not been any significant or really any mortality checks to determine how their thymine levels affect their reproduction. So in normal studies for salmon and trout, we have a baseline level that we can say enough study has been done that if their thymine levels are below 4 nanomoles per gram within their eggs, then they're most likely going to have significant restrictions to their reproduction. But for the lake whitefish, we can't really say that that's the case, because we have not done enough any studies on how the different thymine levels affect their recruitment and how well they're able to bring new progeny into the next population. So basically, this study is very preliminary, and it just shows the need for more research. But yeah, I think that I hit all of his main points. I might be able to answer some questions, but I may have to give you his contact information if you have some more detailed ones.
Nick, I just have a general question. First of all, I find it fascinating that we have an example here of an introduced prey item screwing up the vitamin metabolism of native predators. I mean, that just seems bizarre, but I was wondering in general, for these native predators, is there sufficient individual variation in foraging behavior that there might be selection to avoid that particular type of mussel? Or is the foraging behavior just so generalized that it's unlikely to happen?
It really depends. For lake whitefish, I think my answer is going to be that we don't know enough. There have not been a ton of dietary studies on lake whitefish to see how variable they are. I know that the ones that I caught from Otsego Lake were packed front to back with dressed dracinids.
Okay.
But I can't speak to that. But the salmonids that do have more general diets, your steelhead, steelhead is a good example because they're comparable to lake trout in the length that they live. They do have generally better thymine levels. Their threshold is it's pretty robust. So they do pretty well. Whereas lake trout, which focuses on, for them, instead of dracinids, it's alewife, which also causes thymine deficiency. That's the main, if you think of the species that causes thymine deficiency, usually you think of alewife.
Okay.
They do not do well because they hammer alewife so readily. So yes, it's unsure for lake whitefish, but generally speaking, the more diverse your diet, the less likelihood you are to have thymine deficiency.
Yeah, cool. Thanks.
Yeah, of course.
Great. Well, thanks, Nick. I know the timer's about to go off. We're all going to hear the fun little jingle here in about 2 seconds. There we go. All right. Next up, I had Carrie on my list. Carrie, I see you here.
Hi.
Hi, how are you?
Pretty good.
Good. If you want to get set up, we can get your 8 minutes started and we can get rolling.
Okay. Okay.
Perfect. It just loaded. So now I can see it just fine.
Okay.
Did you want to turn on your video? It's okay if you don't want to, just asking if you were going to turn it on for the presentation.
No, I don't think my camera on this laptop works.
Okay, no problem at all. I'm going to go ahead and get your 8 minutes started then so you can get going.
Okay. All right. So my name is Carrie Minisal. I am a graduate student over at SUNY Oneonta, and I'm just going to be talking about the project that I've been working on for my master's thesis. So I'm interested in the distribution of American eel within the upper Susquehanna River watershed. So American eels, they're super cool. They spawn in the Sargasso Sea out in the Atlantic Ocean, and then they migrate upstream into freshwater systems to grow to adulthood, including the Susquehanna River and its tributaries. So for my thesis, I worked with the Susquehanna River Basin Commission, and we were looking at whether or not American eels are present in any capacity in the Susquehanna River and its tributaries, because historically there were large numbers of American eel, but since about the 1990s, the number of American eel in the system has decreased, largely due to dams. There are, I think, 12 dams within the main stem of the Susquehanna River, and eels just can't get past them. They have a pretty high mortality rate, or they just literally cannot travel over them. We have anecdotal evidence from a lot of anglers that there are still eel up here. So my advisor, Dr. Stitch, and I, along with SRBC, are doing some sampling to see if we can come up with a way that we can consistently detect and survey for American eel. So this summer we went out and we did electrofishing. We paired electrofishing surveys with environmental DNA surveys. So we got around to 19 different sites in the Susquehanna River and its tribs this summer. And so we did electrofishing and eDNA at all of those sites. It's gonna be pretty short because unfortunately we didn't get our environmental DNA sampling results back yet. We sent our samples out to Fish and Wildlife Lab down in Pennsylvania, and unfortunately we were hoping to get them back for the spring, but we haven't received them yet. So right now we just have fish counts from our electrofishing surveys. We did only find one eel out of the 4,424 fish that we found. So we didn't find any eel that way, but we're hoping when we get our eDNA results back, maybe that'll light up like a Christmas tree and we can say, yes, there are American eel here. We just weren't able to detect them through electrofishing. One interesting thing that came out of this was we found one weather loach. He's the bottom picture right here, off to the right. He's invasive. That was one of the first records in Otsego County of weather loach being present. He is no longer present in the Susquehanna watershed. So over this coming summer, we're going to go back out and we're going to repeat our electrofishing surveys and our eDNA surveys at the same 19 sites that we hit this past summer. And then we are going to add more sites within the main stem Susquehanna River. And then we are also going to try some different methods. I'm hoping to go out and go sampling at night, because most of our surveys were done during the daytime when American eel aren't necessarily as active. So we're going to change some things up this summer, and hopefully we'll be able to find more eel and just confirm that they're present. So yeah, that's all that I have.
Great, thanks, Carrie. Are there any questions for Carrie? I know she has a couple minutes left here. Anything anybody wants to ask? Okay, if not, thank you again, Carrie. I have Kate next on my list. Kate, are you here?
I am here.
Perfect. All right, so Carrie, if you want to stop sharing your screen, we'll get Kate set up.
Can you guys see this?
Yep, we're seeing it now. It still looks like it's in the, yep, so you're just going to want to put it into the slideshow.
Yep.
Perfect. Looks great. I'm going to go ahead and get your 8 minutes started and you can take it away.
Okay. So my name is Kate Reardon. I'm a graduate student at SUNY Brockport. And this is my master's thesis proposal. So it's still in the works. It's not quite done yet. It's just a proposal of the research. And this project is going to be on a comparison of lake trout diets among the Finger Lakes using stomach content, fatty acids, and stable isotope analyses. So first, the Finger Lakes, we know that many of us are aware of them. They're a series of 11 semi-parallel glacially formed lakes located in western central New York. And their glacial formation has allowed them to be, or has created them to be very deep, which allows them to be very cold and have highly oxygenated hypolimnions, which support lake trout populations. And although we know that they have suitable habitat in the Finger Lakes, and we have some information on their population trends, the knowledge on their diet is very limited. We do know that they're opportunistic foragers, and they'll consume nearly anything that fits in their gape and enters their thermal range. And we do know that throughout New York State, there's been successive invasions of non-native forage species. So historically, you've had native species such as like whitefish, cisco, slimy sculpin, and yellow perch. But in the past century or so, due to canals and movement of bait fish, you see non-native forage species such as alewife, brown goby, and rainbow smelt. And we do know that the forage bases differ among the lakes. See if I can zoom in here. So you could see in this chart here, the differences in the forage species in each of the Finger Lakes. So you could see, for example, Seneca and Cayuga are the most highly inundated with invasive species. They contain those alewife, rainbow smelt, and round goby. These other lakes are a little more intermediate, where Skinny Atlas is known to be in a more pristine state where it doesn't contain any of those invasive species. It just contains the native cisco and slimy sculpin. Some forage data from DEC also shows that the populations of these forage species differ among the lakes. So with being different species in the lakes and different abundances of those species, we'd like to see how they're appearing in the lake trout diet, which is why diet quantification is so important. There's multiple methods for diet quantification. Each one has pros and cons, but together they provide a great holistic overview of the diet. So stomach content provides an idea of a 24-hour diet, and it's great because it provides a detailed taxonomic description of what's in the diet, but it has downfalls as it's such a short temporal span, and there could be some uncertainty due to unidentifiable partially digested prey, as well as empty stomachs. Fatty acid signatures, which go under the idea of you are what you eat, with fatty acids being transferred from prey to predator, provide an idea of a several-week-long diet. And stable isotope ratios, which typically evaluate the isotopic ratios of nitrogen and carbon to determine trophic structure and sources of organic matter in the food web, provide an idea of a several-month-long diet. So the objectives of my study are to determine the diet of lake trout in each of the Finger Lakes using stomach content, fatty acid, and stable isotope analyses. My second objective is to compare the diet of lake trout among the Finger Lakes and link it to prey availability. So for example, how does the diet of lake trout differ between Seneca, Cayuga, Skinny Atlas, and so forth? And then my third objective is to evaluate temporal changes in the diet of lake trout in the Finger Lakes, So how has it changed over time? So for example, Seneca this past summer of 2023 was the first official record of round goby in that lake. So we want to see if they're appearing in the lake trout diet yet and at what quantities. So my methods, I'll be collecting lake trout through DEC summer lake trout surveys. They set gill nets for 24 hours at a time. And I'll be trying to get 30 lake trout from each lake, and I don't have them from every year for every lake because these surveys are periodic, but I try to get at least 3 samples per lake. And I have samples dating back to 2016. And then I'll be collecting prey using gill nets through DEC and electrofishing, and then seining at SUNY Brockport. And then I will be using those 3 methods of analysis that I mentioned. I'll be using stomach contents, which is, again, pretty straightforward. It involves identifying the contents of the stomach. And it'll be quantified 2 ways, both by percent mass of each prey item, as well as frequency of occurrence of each prey species in the stomachs. I'll be using fatty acid signatures, which uses the belly flap of the lake trout due to its high lipid content and whole prey, assuming that the lake trout are consuming the prey whole. And we use a gas chromatograph mass spectrometer to quantify the fatty acids in both the predator and the prey and try to match them to each other. For stable isotope ratios, I'm using the muscle samples of lake trout due to low turnover rates, and then again, the whole prey. And these will be shipped to a stable isotope facility where they will be analyzed for carbon and nitrogen isotopic ratios using an elemental analyzer. For my data analyses, I'll be using multivariate statistics to make comparisons among prey for their fatty acid signatures and stable isotopic ratios, and among lakes for the lake trout and among time for the lake trout for a given lake. And I'll be using, like I said, multivariate statistics such as non-metric multidimensional scaling, principal component analysis, similarity percentages, Permanova. For the fatty acids, I will also be using quantitative fatty acid signature analysis, also known as QFASA, which takes into account slate metabolism by the predator species and determines the proportions of prey in the diet of the predator based on that. And then stable isotope mixing models will be used to quantify those, the percentage of prey in the diet based on those isotopic ratios. And although I've not done much of this research, we have some preliminary results from some past data, where you could see here in the upper corner, you could see in this NMDS plot that each dot represents an individual lake trout. And you could just see that the lake trout tend to clump up by lake. So you could see Canandaigua, their fatty acid signatures tend to be unique. Same with Skinny Atlas, where then there's a little bit of overlap between Cayuga and Seneca, which have similar forage bases, as you would expect. And in this PCA plot in the bottom, you could see differences in fatty acid signatures among prey. So for example, each one of these dots represents a different individual. And you could see that the alewife are all clumped together and the round goby are all clumped together. And when you match it to this plot on the right, you could see, for example, alewife high in 18-1N9. So then if your predator tissue is high in 18-1N9, you could assume that they're consuming lots of alewife. And this is all important to inform fisheries management in New York by understanding the entire food web from the bottom up to better be able to manage the top predators to maintain a cold water fishery for lake trout in the Finger Lakes. And that's pretty much it.
Great, thanks so much, Kate. And the timer's going to go off here in just a few seconds, so it was perfect timing. I'm going to pause it so we don't have to hear it. All right. And last but not least, I had John Skelton. Do you prefer Danny? I saw you were in here. Oh, you're muted.
Oh, yeah, that's me. Hello.
How are you?
Good. How are you? Yep, I
Good.
can go by John or Danny, whichever is easier for you. My nickname is Danny, so go with
Sure.
that, but it doesn't matter.
Okay, sounds good. If you want to go ahead and get set up, we'll get your 8 minutes started and we'll get rolling.
Beautiful. Can we see this okay?
Yep, we can see it. It does look like I'm looking at it from like the PowerPoint version. So if you want to put it into
Let me get
slideshow.
in presentation mode. Fantastic. Right. There we go. How's that?
Perfect. Looks good. And I'm going to start your timer now, so you're good to go.
Awesome. Thank you. Well, hello, everybody. How are we doing? My name is Danny Skelton, or John, whichever you prefer. And I am a master's student at SUNY Oneonta, and I'll actually be defending in a few weeks here. So I'll be finishing that up pretty soon. So very exciting. And I'm going to be presenting my poster to you, which is focusing on modeling population abundance on artificial spawning beds of lake sturgeon. But kind of getting into it, just starting off. So our project focuses on the St. Lawrence River. I don't know if you can see my mouse or not, but I do have a nice map up there for you. And just for the audience's sake, something to note about the St. Lawrence River, it actually flows from south to north. So actually down here is upstream and over here is downstream. So that gets important later on in this presentation. But essentially, this project happens right on the New York-Canadian border at the Iroquois Dam. And now the Iroquois Dam doesn't have any form of fish passage. It doesn't have any fish ladders, doesn't have any fish elevators, anything that can assist fish moving from one side of the dam to the other. So the New York Power Authority, who is in charge of the Iroquois Dam, created spawning habitat for lake sturgeon, the focus of this project. Lake sturgeon are a long traveling migrant fish. They travel hundreds and hundreds of miles to reach spawning grounds that they've historically returned to time and time again. But the problem with dams is they kind of prevent sturgeon from reaching those spawning habitats. And if you have one large population and put a basically impassable wall right in the middle, you've essentially cut that population into two separate populations that don't interact anymore. And dams also affect spawning habitat. They increase siltation, making spawning habitat inaccessible to sturgeon. Sturgeon need cobble or gravel, large boulders or rocks to spawn on. And then dams also scour the bottom. So they blow that substrate around so thin that sturgeon really can't use it anymore. So in 2007 is when these spawning beds were created, but it wasn't until 2011 that New York DEC took over monitoring this population. And what they did was essentially create a series of transects. So 5 transects for both of these spawning beds. And they used underwater video camera and looked at the sturgeon. I have a photo of what it kind of looked like on that video camera at the very bottom here. Very unique in terms of fisheries. Usually we deal with electrofishing and seine nets. So this was kind of a unique approach. And DEC had all this data from 2011 to 2023, but they didn't really know exactly what to do with it. I mean, sure, they can look at the overall trends shown by the raw data, and it kind of looked like, I don't know, maybe lake sturgeon were starting to decrease in both of these populations over time, but they weren't sure. So that's kind of where myself and my advisor, Dr. Daniel Stitch, came in. And really what our project focused on was going into R and working with JAGs. And then essentially we used a general additive model, which is shortened up to GAM a lot of the time. And in these pictures here, so we created a series of 30 meter by 30 meter little grid cells that made up this whole entire area. And in that way, we can detect sturgeon in association with different transects and get really specific on where these sturgeon are. The problem is when we got this data, we got a bunch of observations. We as scientists are fantastic at observing things. Hey, there's the thing we're looking for. Let's mark that down. Let's get the GPS coordinates of it. They got all these things for sturgeon, which was fantastic. But the problem is we as scientists, when we're looking for something, sometimes it's a little less intuitive for us to think, hey, there's not the thing we're looking for. Let's mark that down. Let's get some data on that, and that'll be really helpful. Which is what happened. We got all these ones, these observations of sturgeon, but we didn't get any zeros. We didn't get any of the dates that DEC went out and saw nothing, which is just as important for data analysis. So essentially what I had to do was I had to go back through every single video recording from 2011 all the way to 2023, get the start end coordinates and get every single date, and essentially recreate all of the transects. That's what you see in these purple lines here. These are all of the transects from 2011 to 2023 recreated, and there are dots in between, and those are sturgeon observations. Now we have our zeros and our ones, and we can further manipulate the data. And then getting into the results here, you can kind of see that up here. So remember, our downstream is up and then our upstream is down. And this was a fairly common trend throughout time. There were always more sturgeon on the downstream beds, which was seen in the raw data, and that was expected. And you can see a lot of cool trends over time, one of which sturgeon, they live a very long time. They can live up to 150 years old. They're known to take breaks during their spawning. So they actually space out. So you can see in 2012, a very highly concentrated dark red dot. It starts to kind of fade out over time, and then it starts to darken back up in 2015. That's those breaks I'm talking about. Females will go to the spawning beds 1 year and may not show up for another 4 to 5 years. So you can kind of see trends like that, which are very cool. But something else we're noticing is that population seems to be spreading out over time. It's not as concentrated. And then looking at the bottom graphs here, it also reflects, again, our downstream population had much more individuals than the upstream population. And then in that very last graph there, it really shows the trend that DEC was concerned about, and we've noticed it as well, is it does appear that the populations, the combined populations, do seem to be declining over time. And currently right now, I'm finishing up chapter 2. So in the summary over here with this little icon, that's essentially explaining the data simulation process, which I won't go crazy into because I know I don't have a bunch of time, but feel free to ask me any questions about it. But essentially we're making simulations and running our model against these simulations to test the accuracy, because we can make a model and it can give us different numbers and different predictions, but unless we're running it against simulated data that we know those numbers are accurate, then there's no way to really test our model. So that's what we've really been doing, and we've been wrapping that up. And I got my results back after the creation of this poster, but it actually turns out that our model has a bias of detection of negative 0.04. So very close towards 0. Our model does have a slight tendency to underestimate individual sturgeon in each of these grid cells, but it's very close and relatively accurate. And this is great for this project. It can be used in years to come by this specific team, but it can also be broadly applied because this model reflects a lot of lake sturgeon behavior and life history too. So it can be applied to a lot of things. So yeah, looks like I'm running out of time there. I think about 13 seconds left-ish. But yeah, that's kind of what I got. Thanks for listening.
Great, thanks, Danny. I'm gonna go ahead
Thank
and
you.
stop the stopwatch here so we don't hear the little tune. Okay, that was everybody that I had on my list for this poster session. Is Alex Yavitz here? I don't think so. He's the only one that was missing today. Yeah, I don't see him in here. Okay, well, either I'm happy to hang out in here if there's any questions that we want to have. I know that the conference closing is at 3:20, so we will be heading back to the main room. So folks, if there's any questions, any final thoughts, we can certainly have those here. Or if you want to head back to the main room where the conference closing will be going on, you'll just hit leave room down in the bottom there, and you should be brought right back to the main room for the conference close.